Hello students, today's topic is molality. First, what is the defined molality? It is defined as the number of mole present in 1 kg of solvent is called molality. Molality is defined as the number of mole present in 1 kg of solvent is called molality. Clear? How to define the molality? The number of mole present in 1 kg of solvent is called molality. Clear? Molality is represented by small m. So molality is equal to number of mole of solute divided by weight of solvent in kg. Clear? We know that mole is equal to weight upon molecular weight. So molarity is equal to weight of solute divided by molecular weight of solute divide weight of solvent in kg. Clear? So molarity is equal to weight of solute divided by molecular weight of solute into weight of solvent in kg. Clear? If in the question the weight of solvent present in gram, so we can write it molality is equal to weight of solute divided by molecular weight of solute into weight of solvent in gram, but we have to multiply with 1000. Clear? Now we are calculating the sum question which is based on the molarity. The first question is 5.55 gram of calcium chloride is dissolved in 500 gram of water. What is molality of the solution? We know that the formula of molality is equal to weight of solute divided by molecular weight of solute into weight of solvent in gram, multiply with 1000. Now we are putting each value. M is equal to, that is the molarity is equal to weight of solute, that is the 5.55 gram, divided by molecular weight of solute. Molecular weight of calcium chloride is 111 into weight of solvent in gram. The weight of solvent in gram is 500 gram. that is the 500 gram into 1000. Now we get the molarity is equal to 0.1 mole. The unit of molarity is equal to mole per kg. Clear? Now, the new topic is parts per billion. ppm, that is parts per million. It is defined as the amount of solute in gram present in 1 million of the solution is called part per million. That is the amount of solute present in 1 million of the solution is called ppm. ppm is equal to, that is the part per million, is equal to amount of solute divided by amount of solution into 10 power 6. Clear? Now, the next topic is mole. Mole. How to define the mole? Mole is the fundamental unit of amount of substance which express weight, volume and number. Mole is defined as, mole is the fundamental unit of amount of substance which express weight, volume and number. Clear? How to define the mole? Mole is the fundamental unit of amount of substance which express weight, volume and number. The first important point is 1 mole of any substance contained 6.022 into 10 to the power 23 molecules. Clear? 1 mole of any substance contained 6.022 into 10 to power 23 molecules. The second important point is 1 mole of any substance occupy 22.4 liter volume. Clear? The second important point is 1 mole of any substance occupy 22.4 liter volume. The third important point is 1 mole of any substance occupy 22,400 ml volume. That is 1 mole of any substance occupy 22,400 ml volume. And one more important point is, we know that mole is equal to weight of solute divided by atomic mass or molecular mass. Clear? Now, there are some questions which is based on the number of mole. The first question is, calculate the number of mole. First, 6 gram of carbon. Second, 7 gram of nitrogen. Third, 10 gram of calcium carbonate. First, 6 gram of carbon. We know that mole is equal to weight of solute divided by atomic mass or molecular weight. Atomic weight or molecular weight. First, 6 gram of carbon. Mole is equal to, first, mole is equal to weight of carbon is 6 gram. 6 divided by atomic weight of carbon is 12. That is 0.5. Clear? That is the 0.5 mole of carbon. The second question is 7 gram of nitrogen. We are calculating the mole is equal to 7 gram. That is the weight of nitrogen is 7 and the atomic mass of nitrogen is 14. That is 0.5 mole of nitrogen. Third, 10 gram of calcium carbonate. We know that mole is equal to weight 10 gram of calcium carbonate divided by molecular weight of calcium carbonate. That is the 40 molecular weight of calcium carbonate is equal to 40 for calcium, 1 carbon, 12 for 1 carbon atom and 16 for 1 oxygen atom into 3, because there are 3 oxygen atom is equal to 100. So mole is equal to weight of calcium carbonate is 10 gram and 100 for the molecular weight of calcium carbonate. Then we get 0.1 mole of calcium carbonate. Clear? Now the second question is, calculate the number of mole in 2.24 liter of carbon dioxide gas at NTP, normal temperature pressure. Answer second. We know that 1 mole of any substance occupy 22.4 liter volume. Clear? Since 22.4 liter volume occupied by 1 mole of carbon dioxide gas. Therefore, 2.44 liter volume occupied by, that is 2.44 into 1 divided by 22.4 is equal to 0.1. Answer. That is 2.44 liter volume occupied by 0.1 mole of carbon dioxide gas. This is the answer. Now, question third, calculate the number of mole of 200 ml of NH3 gas at NTP. Clear? We know that, answer third, we know that 1 mole of any substance occupy 22,400 ml volume. Clear? Since 22,400 ml volume occupied by 1 mole of NH3 gas. Clear? Since 200 ml, that is 200 ml volume occupied by, that is 200 into 1 divided by 22,400 is equal to 0.0089 mole. This is the answer. It means that 200 ml volume occupied by 0.0089 mole of NH3 gas. Clear? This is the answer. Now, the next question is, calculate the number of mole of 90 ml of H2O. The density of water is given. Clear? We know that mole is equal to weight upon molecular weight. Clear? Here the weight in the question, the weight of water is not given. The volume of water is given. Clear? So we know that the formula of density, D is equal to M by V. D is the density, M is the mass, and V is the volume. And density in the question, density of the water is given, that is the 1 gram per ml. that is the V, volume, sorry, that is the D, density, and the volume of the water is given, that is 90 ml. So mass, we can calculate the mass of water, that is the M is equal to D into V, that is the mass of water is equal to 1 into 90. The mass of water is 90 gram. Clear? Now we are putting the value of mass of water, that is the mole is equal to weight of water, that is the 90 gram, divided by molecular weight of water, that is 18. So mole is equal to 5. Yeah. This is the answer. Clear?
Now, some more question related to the mole concept. The first question is, calculate the molecule of 1.8 gram of glucose. Answer first. We know that 1 mole of any substance contain 6.022 into 10 to the power 23 molecules. Clear? In the question, the number of mole of glucose is not given. The weight of glucose is given. So firstly, we have to calculate the number of mole of glucose. Then we can calculate the molecule of the glucose. Clear? So we know that mole is equal to weight of solute divided by molecular weight of solute. Here mole of weight of solute is 1.8 divided by molecular weight of glucose is 260. We get 0.0069 mole of glucose. Clear? We know that since 1 mole of substance contain 6.022 into 10 to the power 23 molecules. Therefore, 0.0069 mole of glucose contained 0.022 into 10 to the power 23 into 0.0069 divided by 1, and finally we get the molecule of 4.15 into 10 to the power 21 molecules. This is the answer. This is the answer. Clear? Now, second question is, calculate the electron, proton and neutron in 2 by 3 mole of CH4, that is methane. Answer second. We know that 1 mole of any substance contain 6.022 into 10 to the power 23 molecules. Clear? Since 1 mole of CH4 contain 6.022 into 10 to the power 23 molecules. Therefore, 2.3 mole of 2 by 3 mole of CH4 contain 6.022 into 10 to the power 23 into 2 by 3 molecules. Clear? First we are calculating the number of electron. The number of electron in CH4. The number of electron in CH4 molecule, that is equal to 10 electron. Clear? The number of electron in one molecule of CH4 is equal to 10 electron. Clear? Therefore, 6.022 into 10 to the power 23 into 2 divided by 3 molecules contain 6.022 into 10 to the power 23 into 2 into 10 divided by 3 electron. Answer. Now we are calculating the number of protons in 2 by 3 mole of CH4. We know that we know that 1 mole of CH4, that is methane, contain 6.022 into 10 to the power 23 molecules. Clear? Therefore, 2 by 3 mole of CH4 contain 6.022 into 10 to the power 23 into 2 divided by 3 molecules of CH4. Clear? Now we know that one molecule of CH4 contain 10 proton. Therefore, 6.022 into 10 to the power 23 into 2 divided by 3 molecules of CH4 contain 6.022 into 10 to the power 23 into 2 divided by 3 into 10 proton. Answer. Clear? Clear? Now in the second question, the last part is calculate the number of neutron in 2 by 3 mole of CH4. Clear? We know that 1 mole of CH4 contain 6.022 into 10 to the power 23 molecules. Clear? Therefore, 2 by 3 mole of CH4 contain 6.022 into 10 to power 23 into 2 divided by 3 molecules of CH4. Now the last part is calculate the number of neutron in 2 by 3 mole of CH4. We know that 1 mole of one molecule of CH4 have 6 proton, 6 neutron. Therefore 6.022 into 10 to power 23 into 2 divided by 3 molecules of CH4 contain 6.022 into 10 to power 23 into 2 divided by 3 into 6 neutron. This is the answer.